Welcome back, everyone. Today, we will be learning about LCM, or the least common multiple. It is a fundamental concept in arithmetic, particularly in dealing with multiple numbers. The LCM of two or more numbers is the smallest number that is a multiple of each of the given numbers. It is crucial in various mathematical operations and real-life scenarios, and is used extensively in fraction operations, time and distance calculations, and scheduling. One of the methods to find the LCM of two or more numbers is to list the multiples of each number. For example, let's take the numbers 4, 6, and 8. We can list down the multiples of these numbers. So we have 4, 8, 12, 16, 20, 24, and 28. Then we have 6, 12, 18, 24, and 30. Finally, we write the multiples of 8, which are 8, 16, 24, and 32. Right now, we have just written a few of their multiples. We can extend these lists if needed. Now we scan through the three of them and look for a value that appears in all of them, starting from the left. Here, we can see that value is 24, and so that is our least common multiple, as it is the first value that is common in all three lists. The second method is prime factorization. That is to write our number as multiples of prime numbers. Or you can say that it is writing the factors of the number. An easy way to approach this is to draw tree diagrams. We write the main number in the uppermost circle and its factors in circles underneath. Let's take the numbers 6, 10, and 15. Since we are doing prime factorization, we start dividing the number starting from the lowest prime number, which is 1, but since a number divided by 1 is the same number, we move on to 2. 6 is divisible by 2 and gives us the factors 2 and 3, which are both prime numbers. Hence, we move on to 10 and divide that by 2 as well and get the factors 2 and 5. Lastly, we make the tree diagram for 15. Since it is not even, it cannot be divided by 2, therefore, we move on to the next prime number, which is 3. And that helps us rewrite 15 as a product of 3 and 5. Now, we list down all these prime factors for each number. Then, we select the maximum powers of each of the factors. We start with 2. The factors of 6 and 10 both include just one value of 2, so we can circle either of them. Then we have 3. Both the factors of 6 and 15 just include 1 3 each, and so we can circle a 3. The next prime factor is 5, and similarly, we can choose 1 5, as that is the highest power available in either the factors for 10 or 15. Now, we multiply these circled numbers and get the least common multiple, which in our case is the product of 2, 3, and 5, which is 30.
Time for a pop-up quiz. Find the LCM of 12 and 18. Please pause the video to try this question yourself.
To further help understand this method, let's do an example that shows how LCM can be applied in real life. The example follows. Imagine you work in an office where there are 2 cleaning staff members responsible for maintaining the cleanliness of the meeting rooms. One staff member can clean a room every 8 days, while the other can clean a room every 12 days. Your goal is to find out when both staff members will finish cleaning a room on the same day so that you can plan the cleaning routine efficiently. To solve this, first we extract the key information. Member 1 cleans the room every 8 days, and Member 2 cleans the room every 12 days. And we need to find when both the members will clean the room together, or an overlap in their schedules, which is basically asking us to find common multiples. Therefore, we start by finding the least common multiple. Now, let's first solve this by listing the common multiples. The multiples of 8 are 8, 16, 24, 32, and the multiples of 12 are 12, 24, 36, and 48. Here, we can compare and find the LCM to be 24. Now let's do this using prime factorization. First, we will make a factor tree for 8. Dividing it by 2 gives us 2 and 4. We can further divide 4 into prime numbers by dividing by 2. Now, we can write 8 as a product of 2, 2, and 2. Moving on, we make the factor tree for 12. We divide it by 2 and get 6, which can be further simplified into 2 and 3. Therefore, 12 can be written as 2 times 2 times 3. Now, we look for the maximum powers for each prime factor. 8 has 3 2's in it, while 12 just has 2 of them, so we circle the 3 2's since it is the greater value. We just have one value of 3, and so we just circle that since it is the greatest number of 3 available. So we can write the LCM as 2 times 2 times 2 times 3, which gives us 24. What this answer tells us is that both staff members will finish cleaning a room on the same day every 24 days, and this helps the manager schedule accordingly so they can avoid overlaps.